Hey guys, in this screencast I am going to show you how to use the equation that we have for projectile motion to determine the speed and height of an object at any given time. And we're going to use calculus to do that. So we're going to start by just reviewing really quickly what is the equation for projectile motion that we're using, and that is h equals negative 16 t squared plus v naught t plus h naught. The v naught is the initial velocity, and the h naught is the initial height. This h right here is the height of the object at any given time t. Okay, so the first question I'm going to go through is an object being launched with an initial velocity of 120 feet per second, and it has an initial height of 3 feet. What is the speed of the object after 2 seconds? The first thing I'm going to do is I'm going to substitute the initial velocity, initial height into the equation. So h equals negative 16 t squared plus velocity of 120, so 120 t, and an initial height of 3, so plus 3. Now, to find the speed of an object, you need the derivative of the position, because the derivative tells you the change in something. So the change in the position tells you the speed. So what we're going to do is we're going to take the derivative of this function, so h prime. And to do that, we're going to use our derivative rules. So the first thing we want to do is take this power of 2 and multiply it by the coefficient. So that gives me negative 32. And then we subtract 1 from that power, so t is now to the power of 1. And in the second term, t is already to the power of 1, so when I multiply that by 120, I get 120. And when I subtract the power on the t, now it's t to the power of 0, which is just 1. So there's no point in me writing t to the power of 0, and there's no point in me writing times 1 either. The 3 goes away completely, because technically it had a t to the power of 0 on it, and the 0 got multiplied by 3, and that made 0. All right, so here is our speed function. So when it says, what's the speed of the object after 2 seconds, that means I can substitute a 2 in for t. So h prime of 2. So negative 32 times 2 plus 120. And your answer is 56. Okay, now we're going to tackle the question, when does the object reach the maximum height? So if you think about it, when the object reaches its maximum height, it's going to have a speed of 0, because it's going to be going up and then it's going to be going down. So for like a brief second in time, it will have a speed of 0. So to find the maximum height, we want to set our speed function, which is h prime, equal to 0. So our speed function was negative 32t plus 120. And now I'm just going to set that to 0. So 0 equals negative 32t plus 120, and solve for t. So subtract 120 from both sides. So negative 120 equals negative 32t, divide by negative 32, so 3.75 equals t. So what is the object's maximum height? So we already know that at 3.75 seconds, the object is reaching the maximum height. So we're going to go back to the position function now, because the position function tells us where the object is at any given time. So it's negative 16t squared plus 120t plus 3. And I'm going to substitute 3.75 in for t, because I know that it's reached the maximum height at that point. So we'll do h of 3.75. I'm going to run out of room here. So I'm just subbing in 3.75 in for t. And when you throw that into your calculator, you get 228 feet. When would the object hit the ground? Now this is a little bit trickier. So let's think about what we have here. We have this parabola that's going like this, where time is our independent variable and height is our dependent variable. So we know the height at any given time t, and we've already determined that right here, time of 3.75 seconds, and the object is 228 feet. Okay, so what we really want to know is what the time would be right here, so at h equals 0. So for this, again, we are going to be using the position function because that's the one that relates the height and the time. So I'm going to go h equals negative 16 t squared plus 120 t plus 3. And now we're going to try to figure out what t is when height is 0. So I'm not talking about the initial height, we're talking about the current height. So I'm going to put a 0 right here. Okay, now, if it weren't for this middle term, this actually would be pretty easy. I could just move the 3 to the other side, divide by negative 16, and take the square root. Unfortunately, that term is there, so what we're going to have to use is the quadratic formula, which I'm sure you all know and love. So let's just review what that is. So t equals negative b plus or minus the square root of b squared minus 4ac over 2a. This formula works to solve a quadratic equation anytime. Factoring is another way to solve a quadratic, but in this case we're unlikely to find good factors, so rather than waste our time trying to do that, we're going to do it this way. Now don't forget that your equation for a parabola is ax squared plus bx plus c. So these a, b, and c are these numbers right here that I'm going to sub into the equation. All right, so negative b is the opposite of b, so that's negative 120 plus or minus square root of 120 squared minus 4 times negative 16 times 3 over 2a. So that's 2 times negative 16. Okay, now when I'm doing these problems, what I like to do is simplify under the radical. So I'm just going to throw that piece into my calculator, and I'm going to get 14,592 under there. Okay. Now you're going to have your two scenarios. This part right here is really key to this equation. In one case, we're going to go through all of it with an addition, and then we're going to do it again with subtraction. So in your calculator, you're going to go negative 120 plus the square root of 14,592, get that answer, and divide it by negative 32, because that's what that is down there. And then you're going to do that again with a minus. So when you go through with a plus, you're going to get negative 0.025 as your answer. And when you go through with the minus, you're going to get 7.525. Now, this first answer of negative 0.025, that's right here on the graph, which is back in time. Since the object was launched at 3 feet, it was never at this height of 0 at negative 0.025. So this 7.725 is what we're looking for. That is the x-coordinate for that point. All right, what would be the object's speed when it hit the ground? All right, now we know that it hits the ground at 7.525 seconds because we just calculated that in the last section. And the question's asking us about speed. So we're going to need to use the speed function, which we derived in the first section, which is negative 32t plus 120. So now all I have to do is substitute that time in for t. So I'm doing h prime of 7.525. So I get negative 32 times 7.525 plus 120. So my answer is negative 120.8, which you might think is a little weird for a speed, by the way, feet per second. But the idea is that when an object is on the way down, the speed is actually negative. So it's okay to get a negative number for speed. I hope this helped, but if it didn't, I highly recommend watching it again and taking notes. Have a good day.